MIT researchers analyzed a powerful cyber attack known as a website fingerprinting attack and then developed strategies that dramatically reduce the attacker's chances of success. Malicious agents can use machine learning to launch powerful attacks that steal information in ways that are tough to prevent and often even more difficult to study. Attackers can capture data that leaks between software programs running on the same computer. They then use machine learning algorithms to decode those signals, which enables them to obtain passwords or other private information. These are called side channel attacks because information is occurred through a channel not meant for communication. Researchers at MIT have shown that machine learning assisted side channel attacks are both extremely robust and poorly understood. The use of machine learning algorithms, which are often impossible to fully comprehend due to their complexity, is a particular challenge. In a new paper, the team studied a documented attack that was thought to work by capturing signals leaked when a computer accesses memory. They found that the mechanisms behind this attack were misidentified, which would prevent researchers from crafting effective defenses. To study the attack, they removed all memory accesses and noticed the attack became even more powerful. Then they searched for sources of information leakage and found that the attack actually monitors events that interrupt a computer's other processes. They showed that an adversary can use this machine learning assisted attack to exploit a security flaw and determine the website a user is browsing with almost perfect accuracy. With this knowledge in hand, they developed two strategies that can thwart this attack. The researchers found that the attack actually records a computer's timer values at fixed intervals and uses that information to infer what website is being accessed. Essentially, the attack measures how busy the computer is over time. A fluctuation in the timer value means the computer is processing a different amount of information in that interval. This is due to system interrupts. A system interrupt occurs when the computer's processes are interrupted by requests from hardware devices. The computer must pause what it is doing to handle the new request. When a website is loading, it sends instructions to a web browser to run scripts, render graphics, load videos, etc. Each of these can trigger many system interrupts. An attacker monitoring the timer can use machine learning to infer high-level information from these system interrupts to determine what website a user is visiting. This is possible because interrupt activity generated by one website like CNN.com is very similar each time it loads, but very different from other websites like Wikipedia.com. The researcher says that one of the really scary things about this attack is that they wrote it in JavaScript, so we don't have to download or install any code. All we have to do is open a website. Someone could embed this into a website and then theoretically be able to snoop on other activity on our computer. The attack is extremely successful. For instance, when a computer is running Chrome on the macOS operating system, the attack was able to identify websites with 94% accuracy. All commercial browsers and operating systems they tested resulted in an attack with more than 91% accuracy. There are many factors that can affect a computer's timer, so determining what led to an attack with such high accuracy was akin to finding a needle in a haystack. They ran many controlled experiments, removing one variable at a time, until they realized the signal must be coming for system interrupts, which often can't be processed separately from the attacker's code. Once the researchers understood the attack, they crafted security strategies to prevent it. First, they created a browser extension that generates frequent interrupts, like pinging random websites to create bursts of activity. The added noise makes it much more difficult for the attacker to decode signals. This dropped the attack's accuracy from 96% to 62%, but it slowed the computer's performance. For their second countermeasure, they modified the timer to return values that are close to but not the actual time. This makes it much harder for an attacker to measure the computer's activity over an interval. This mitigation cut the attack's accuracy from 96% down to just 1%. Building off this work, the researchers plan to develop a systematic analysis framework for machine learning assisted side channel attacks. This could help the researchers get to the root cause of more attacks. They also want to see how they can use machine learning to discover other types of vulnerabilities.